what we've been working on the unit circle, guys, every day isn't going away. We're going to review it again today, go over some of the tricks of the trade again. But here's the biggest thing. I have told you we have to know it like we know our multiplication facts, okay? And it's not going to go away. So we're going to have this 5-minute quiz tomorrow, and your unit circle is going to look just like this one, and you're going to have 5 full minutes, which is way more time than we really should need, okay? If you're not feeling comfortable yet, watch the video from yesterday. It's very important that you know. The feedback I got from students all day yesterday, especially ones that were really nervous about it in the beginning, were like, oh, it makes complete sense when you notice all the patterns, and that it really makes sense. It's mathematically sound, okay? So in today's lesson, in tomorrow's lesson, in Monday's lesson, there's more reviewing of the unit circle. It's going to keep popping up because coming up soon in our very near future, knowing the trig values, the trig function, sine, cosine, and tangent of the unit circle are like one step in a big problem. And we're not going to sit there and do SOHCAHTOA and all that stuff to find them. We want to just know it quickly, okay? Just like when, I keep using learning our multiplication facts as an example. There is a reason your 4th or 5th grade teacher made you memorize all of those tables, right? And you thought it was really hard, and you'll never learn it, or maybe you thought you would. I never thought I'd learn it. But now you use 5 times 6. You do it really quick in your head, and it's one step in a big problem. That's what the unit circle is. We have to know these values like within 10, 15 seconds, like I was modeling for you yesterday, which I'll model for you again today. Before I say but, and this is going to lead us into today. We talked in the last few days about how the unit circle is just a whole bunch of right triangles. Special right triangles, but all right triangles, right? And it was kind of confusing at first because it's a circle, but when I beautifully drew all the right triangles in there, you could see it's really just 3-sided right triangles, right? What is unique about the unit circle right triangles, though? Anybody remember? Like the word unit is a hint. Zach? What's unit mean? What's special about what's one? What's one? In every single right triangle, there is something that's a 1. What is it? Think back to our notes where I reviewed 30, 60, 90s, 45, 45, 90s. Your hypotenuse is 1, okay? The hypotenuse is 1 because the radius, these are all a bunch of radiuses or radii that are 1. So that was what's special about that. Where we're going with this today, though, is we're going to have right triangles that have all different lengths of hypotenuses, okay? And so let's start looking at that. So what we have here is a terminal side of an angle, and it contains this point. And what we're going to do is find exact values, I'll come back to that term, of sine and cosine for theta. Exact values. You're going to hear that all the time. Find the exact values of sine or exact values of tan or whatever it may be. That means you leave your radical in your answer in terms of that radical. You don't put it in your calculator and get a decimal, okay? And here's what I'm talking about. So before we get to that, let's use this little space right here to go over something from geometry. So way back in geometry, I know it's been a few years, you guys did a whole bunch of stuff with right triangles, okay? So a right triangle is a triangle where one of the sides is a right angle, all right? And you also learned back in geometry that the 2 sides that make up your right angle are called legs. And back then you labeled them A and B, and it didn't matter which one you called A, which one you called B at all. What do we call the hypotenuse? Anybody remember? C, okay? And that still holds true, okay? We can still call them A, B, and C. And you were given a formula back then that was used to find the missing side of a right triangle. Right. A squared plus B squared equals C squared. Bonus point for do you remember what it's called, Remy? Good. Pythagorean theorem. Okay, so A and B are your legs, C is your hypotenuse. We are going to be using that still because we're just going to be working with a bunch of right triangles. Now, A, B, and C are still used, like I said, but a lot of times we might call them different letters, like X Y, and R for a radius. Tomorrow we're actually going to have different letters. The whole point of it is you can call them George, Steve, and John as long as you know the relationship between them. Okay, so you'll see me toggle between these two. Bottom line is you add the squares of both your legs and it will equal the square of your hypotenuse. Okay, so whatever we call them, it's the same concept. Now, let's go ahead and go to this first problem. So what we have here is a point of negative 5, 3. There's a reason why it's in quadrant 2. Because to get to negative 5, 3, we always start at the origin, and in this case, we'd go left 5, up 3. And what this does, by going left 5, up 3, is it creates a right angle with the x-axis. And in a minute, we won't be given a little head start with the point. We're going to have to figure out where our right triangle is. But most of what we're doing today is we're going to be given some information, and we're going to have to draw a right triangle in the correct quadrant. So right at its base, guys, most important right now is let's not forget what we already know, all right? Every single one of you, I know knows how to maneuver around around the coordinate plane. You know you start at 0, 0, and you either go left or right and then up or down, okay? So there's a lot of that going on. And so what is this asking for us to find? Sine and cosine. So let's go over how to find sine and cosine. And we talked about it for a minute the other day. Let's go a little deeper into it. We talked about back in geometry, most of you, I think you told me, had learned about SOHCAHTOA. And I don't want to go too fast over this because even though I've covered it a few times, I had a student last period who was like, I don't get it. What does that mean? Okay. So for anyone that is struggling with it, pay attention. SOHCAHTOA are 3 main trig functions, sine, cosine, and tangent, and the relationship in the triangle of how to get those. So sine is your opposite side over your hypotenuse, cosine is your adjacent side over your hypotenuse, and tangent is opposite over adjacent. And we're going to go over how to tell which side's opposite, which side's adjacent, and so on, okay? That's important too. So right away, I need sine, which is opposite over hypotenuse. Well, I think you guys will agree that we're missing our hypotenuse. We're going to need that. That's why I introduced or reintroduced Pythagorean theorem to you. So let's go ahead and find our hypotenuse using whichever version of this formula you want. All right, so square the 3, square the negative 5. I don't need to see that work. You could do that in your head. 9 plus 25 is 34. And remember, we want r, not r squared. So we're going to take the square root of both sides. And when we do that, don't forget, you get a positive and a negative of your solution. And oftentimes, we're going to end up with a radical as our solution. Okay? When won't we? Well, when that number is a perfect square. If I had added these two numbers together and gotten like 100, when you do the square root of 100, our answer would be 10, okay? But a lot of times we have radicals as part of our triangle, right? Now, here's where in each situation you have to decide, are you going to keep the positive or the negative version of that solution? It's going to change depending on the situation. Fun fact, this side, your longest side, your diagonal is called your hypotenuse, is always positive. The hypotenuse is always positive. Think about, we've kind of interchanged the word hypotenuse with radius. A radius can't be negative. It's a distance from the center of a circle, so it's always positive, okay? So since that's the part of the triangle we're finding, we're going to keep the square root of 34 positive. Okay. Now, I've told you before I'll have like flashbacks of past years of grading something or teaching something. This next little concept I'm going to go over is another one I feel like I've rushed through at times and realize that not everybody is super clear on what's adjacent, what's opposite. And that's super important. That's how I'm going to come up with my final answer, is with those relationships. Okay. So we have to find where theta is. In all of the triangles that we'll be drawing on the units on the coordinate plane, and I'll show you again with 2 more examples in a moment, your theta will always be at the origin. So you have a three-sided triangle, three angles in the triangle, of course. One of them is a right angle, and one of them is theta, and that theta is always going to be at the origin. It will never be out in the middle of your quadrant, okay? And that matters, because picture yourself standing where theta is, okay? I'm standing where theta is. I have to figure out what's opposite of where I'm standing, what's adjacent to where I'm standing, and what is the hypotenuse. Normally, we don't get confused on the hypotenuse. Hypotenuse is that diagonal. It's the longest side, okay? And so the opposite side, I think about myself standing here, and the opposite side like across the street. I can like wave to it, but I'm not touching it. See how I'm not, this angle is created by this side and this side. This is the one side this angle's not engaging with. So that's my opposite side. The adjacent side, I guess you figured by default that that's our adjacent side, but it's also the side that helps create that angle, right? We have our hypotenuse, and our adjacent side is creating that theta, right? Now, it's just about grabbing the numbers. Sine is opposite over hypotenuse. Opposite is 3. Hypotenuse is the square root of 34. Cosine is adjacent over the square root of 34. And I don't know about you guys, but at first, it feels a little uncomfortable leaving our answer like that. Up through Algebra 2, you never leave radicals in our denominator. At this level and above, we're allowed to leave radicals in our denominator, as long as it's simplified. Like we wouldn't leave the square root of 100 in the denominator, that would become a 10, okay? But there are times, well, there's lots of times. In this class, as you know, a lot of multiple choice questions on test. Your AP exam is going to have a ton of multiple choice questions. The SAT has questions like this. In those situations, you might see a radical not left in the denominator. So in our next example, I will show you how you would quote unquote fix it, okay? But for an FRQ, for an open-ended question in your homework, you are allowed to leave a radical in your denominator. It's perfectly fine, okay? But we'll go over how to get rid of it in a second, and you'll see it's really easy, and it's a skill you have to know anyway, okay? All right, let's look at our next question. Let theta be an acute angle such that sine of theta is 5 over 6, and theta lies in quadrant 1. Look, they told us where it is, right? So then we're going to find cosine and tangent of that triangle. So let's practice. So a big part of the skill today of knowing how to do every single problem is how do I draw a right triangle correctly in each of the 4 quadrants, okay? So I'll be doing a few examples with you, but we always start at the origin. It already told us quadrant 1. So you make your hypotenuse, radius, whatever you wanted to call it, out into the middle somewhere, not exact. These are not drawn to scale. Your hypotenuse will always go right out into the quadrant. You will always make your right angle with the x-axis. I'll explain why momentarily. And theta is always at the origin. So there is how you draw a triangle in quadrant 1. We will cover all 4 quadrants by the time I set you free to work on homework, okay? So we have our triangle. Now, let's go back and see what they gave us. Sine of theta is 5 over 6. Okay, go back to SOHCAHTOA. That is your opposite side. This is your hypotenuse, right? Sine is O over H. So opposite of theta, I'm standing there across the street, the side that I'm not touching would be 5, and my hypotenuse would be 6. And what do I need? I need cosine and tangent. Well, if I need cosine and tangent, I'm going to need this side. Here comes Pythagorean theorem again. Notice I have my hypotenuse this time. I'm missing one of my legs. Okay, so 5 squared plus whatever you want to call it, b squared, 5 squared. So I'm going to get 25 plus b squared equals 36. You could totally skip some of these steps. You'll get 11 when you subtract 25 from 36. Square root both sides. We get positive and negative square root of 11. how do we decide which one we're going to keep, positive or negative? Look at the coordinate plane. You've heard me say it, you're going to hear me say it a million times. We have to respect the coordinate plane. If you go left or down, that number's negative. If we go up or right, it's positive. Nothing's changed, okay? So are we going to keep the positive or the negative? The positive, because we're going to the right? So this side is going to be positive square root of 11. Okay? If it helps you, not required, you could label all these sides. Hypotenuse, that side would be opposite and adjacent. And now we go back to SOHCAHTOA and write our ratios, our fractions. Cosine is A over H, adjacent over hypotenuse, and tan is O over A, opposite over adjacent. And this is full credit. Perfectly fine to leave that radical in the denominator, but as I said, we need to go over how to clean it up and get the radical out of the denominator, just because sometimes answers are written that way, and you need to know how to recognize them, if that's what needs to be done. So here's the thing, guys. Just like an equation, you can do anything you want to a fraction. You can do anything you want as long as you do it to the bottom and the top. Here's what we're going to do. It's called rationalizing the denominator, and I think we've done it before in here. You definitely did in algebra too. So let's just do a quick recap. What we're going to do is multiply our denominator by its identical twin, not changing signs or anything. Whatever the radical is, we're going to multiply it by its identical twin. What you do to the denominator, you must do to the numerator. Okay, in my numerator, can't multiply them together inside or outside, so they just hang out. 5 on the outside, 11 on the inside. Now, the square root of 11 times the square root of 11 is the square root of 11 times 11 is 121. What's special about the square root of 121 is that it's a what? What's 121? Perfect square, 11. So, did I need to do this work? No. If you multiply a radical by its identical twin, you're left with the number underneath called the radicand. So we don't need to worry about showing that work anymore. If I do the square root of 4 times the square root of 4, quick, what's the answer? 4. Zach? 1 million, I'm being lazy, I'm not writing it all out, times 1 million. Square root of 1 million times the square root of 1 million, what does it equal? 1 million. Okay? No, I got to know. Square root of 107 times the square root of 1, what's the answer? 107. Okay. Okay. Well, you could, but you'd still end up with the same answer. But that's just a shortcut. It should be, rationalizing the denominator, you guys saw, is super, super easy. You totally could leave it like that, like I said, but you need to be able to recognize if the radical is not in the denominator. I know, Zach, I'm just picking on you. It's okay. Okay, another one. Theta terminates in quadrant 3. Tan, blah, blah, blah. Fine. Let's draw a triangle in quadrant 3. We always start at the origin, and we make our hypotenuse out as far as you want. Make a right angle always with the x-axis. Theta is always at the origin. Okay? No negotiating that. Theta is always there. Your right angle is always going to be with the x-axis. I said I was going to talk about why. It's easiest to tell when we do it with a point. Let me just show you again really quick. How did we get to this point, negative 5, 3? Starting at the origin, how do you graph that point? We go left 5, up 3. Simply by negotiating your way around, navigating your way around the coordinate plane, creates a right angle every time, right? You're either going to go left or right, and then up or down. So it's always going to create a right angle with the x-axis, okay? And so tan is opposite over adjacent. So opposite would be 4, adjacent would be 7. Take a second and look at that, and I want to see if anybody has anything to say about what I just drew and what doesn't look right. Something's not quite right. If anyone can figure it out. Something's wrong with what I just drew. No, it's fine. It's in the right quadrant. I'll tell you this, I drew the triangle correctly. I put 7 and 4 in the correct places, but there's something not right. Come on, what is it? Yes. What? Give me more. Yes. Respect the coordinate plane. Good job, Austin, really. When you graph, don't forget what you learned in Algebra 1. When you go to the left, you're negative. When you go down, you're negative. But I did what it said, right? It didn't say -4 over -7. Why, guys? What is -4 over -7? That even makes me uncomfortable to write it, right? It just feels like wrong. None of you would leave your answer like that. You would be like, oh, negative over negative becomes positive. Well, our math is correct. You know, it's negative over negative simplifies to positive. Quadrant 3 is tricky. We have to be on our toes. Anytime you have to do a quadrant 3 triangle, watch for that, what Austin saw, which is those signs, okay? Okay, so there are my two sides. I'm looking ahead. I'm going to need to find sine and cosine. So I need my hypotenuse, right? Good? Did you have a question? No, I want to hear it. It's fine. When I saw, what I'm going to do right now, they're negative. And I'm going to make a connection for you in just 1 second with that too. Stay with me. Yeah, please ask if you don't understand something. Okay, so these are legs, right? My A and B are X and Y. So -4 squared plus -7 squared. And technically, Jocelyn and anyone else that's questioned that, whether I remember the negative or positive here or here wouldn't change this answer at all, right? Because if I square a +4 or square a -4, I'm going to get 16. So right here, nothing would be wrong. It wouldn't be on my radar necessarily that something was wrong. So that's a 65, sorry. So I'm getting, sorry, got a little messy there. C squared equals 65, square root of both sides, C equals positive or negative, square root of 65. Eight, where, what? Where? Could you write what? For, are you asking if you can simplify the square root of 65 to that? No. You're saying, are you asking me if this is 8 square roots of, did we say 1? No. No. I'm trying to think of what you're thinking about. First of all, you wouldn't leave this like this. The square root of 1 is 1, so that would be 8. But the square root of 65 does not equal 8. 65 is not a perfect square, okay? I think maybe you're getting confused with 64 or something. I'm not sure. I'm going to give that more thought. So we're going to keep the positive version, which is the square root of 65, because it's a hypotenuse, okay? So back to what I was saying about the signs. If you had kept these positive, kept them positive in here, what you would have is this would be your hypotenuse. It would still be the square root of 65. These would have been positive. These answers would have been wrong, okay? Because sine is opposite. Opposite side is -4, right? You would have had a 4 there, so your final answer would have been wrong. Opposite over hypotenuse. And adjacent, this one's the adjacent over hypotenuse. So common error is when you have a quadrant 3 triangle in your final answer, there'll be a sign mistake. Guys, think ahead for a multiple choice question. What do you think one of the choices are going to be? You're going to have a positive and negative of those numbers because that's a common mistake. You're not going to fall into those traps. Quadrant 3, tricky. Tricky. Okay? And again, leaving the radical in the denominator is fine, or rationalizing is fine. Okay? All right. Last thing we have to talk about before I set you free is here's that opportunity to review for the unit circle. So I keep talking about our 5-minute quiz, our 5-minute quiz. Remember, that's it. After that 5-minute quiz, it's not about filling this in super fast anymore. What we are heading towards, what is the reason we're doing this, hate the word memorization, is for the future problems where you are asked what is sine of pi over 6 or what is tangent of 3 pi over 2 and coming up with those answers. This has to be in your brain to find those answers, okay? That's why we're only doing one 5-minute quiz on this, and then we're going to switch to those trig quizzes I talked about yesterday. Here is your chance in the notes and when you get to the homework to not take a shortcut. Try to quiz yourself. The less you depend on this, the faster it's going to get into your brain like your multiplication facts did once upon a time, okay? So trust me, trust the process, okay? Let's review the process, all right? So what we're being asked here is for quadrant 1's trig functions. We have sine, cosine, and tangent of our pi over 6, our pi over 4, our pi over 3, and also the degrees are written there. Told you we don't use degrees a ton. We really want to be familiar with our radians. Okay? Process. If I need to know sine of pi over 6, we start with our denominator. I get my ordered pair from my denominator. What did I drill into your brain yesterday? When I see a 6, I know I'm going to start with what in my numerator? Square root of 3. If we know who starts the party, which is the square root of 3, the rest of it falls into place. The only time I've used the word memorize is right here. That's it. Because as I showed you yesterday, for those of you that weren't here, you need to watch the video. For those of you that need a refresher, watch the video. Once you know that, you start remembering, oh yeah, all the denominators are 2, all of them. And the only other fraction that's ever hanging out with square root of 3 over 2 is 1/2. Okay? What is sine of pi over 6? Quick, what is it? I'm answering this. What is sine of pi over 6? Sam. Dan? Yeah. Half. Hey, guys, let's review. We're not making this connection. In algebra and in trig, we call that an XY. In trig, we call it cosine and sine. All of this, the whole point of what we're doing is so that you can answer these questions, sine, cosine, and tangent of any angle on the unit circle. Where does that come from? Your ordered pair. So we get sine and cosine from your ordered pair, and then we have our little tan trick, which we'll review. So don't fall into the trap we talked about yesterday, because a lot of times you're filling in the blank or answering a multiple choice question, they put sine first. We're not going to fall for it. Cosine, alphabetical order, comes first, and sine is 1/2, right? We're back? We're back? Okay, so cosine would be this. As a quick review, I gave you 3 options for tan, okay? I gave you 1, I gave you square root of 3, I gave you square root of 3 over 3, okay? Those are your options for tan. If you have to memorize them, I'll use the M word again. Denominator of 6, which one is it? Fast. Square root of 3 over 3, is that what you said? Okay, let's review our tan tricks, guys. Square root of 3 over 3, what I see, squint, see it with me, 3 plus 3 is 6. Denominator of 6 is the 3 over 3, which is 6. Let's jump to the other one, because these are the two that we confuse. Denominator of 3, square root of 3. They match. It's a 3 and a 3. They're the same thing. Okay? So we are not going to confuse these two anymore. If you're a denominator of 6, you're 3 over 3. All of these are quadrant 1, so everybody's positive in quadrant 1. Remember, all students take calculus. So all of these are positive, but get this in your brain. Okay? Super important. And quick. It's easy. We got it. All right? We need to do pi over 4. So go through the process again. Start with the denominator. All of my denominators are 4. Those are my middle angles. I'm seeing it up here. I didn't memorize it. And I can see, oh yeah, those are my favorites because the cosine and sine values are the same. Yes, sir. Three. Square root of 3. Uh-huh. Which one? Here?
Yeah.
Well, because this is sine and cosine. Sine and cosine come from the ordered pair, Austin. And then these are your only options for tan. Those are your tans.
Oh, they're like completely separate.
1, 2, 3.
Okay.
3 separate things. Every angle, you got to know 3 things. Sine, cosine, tangent. And later, they have best friends called secant, cosecant, and cotangent. We'll have to know those. Okay, good, good. We're clearing up all of the places where we can make mistakes. All right, so this one's pretty easy not to mess up in quadrant 1, right, because they're both the same. But sine is our y value. Cosine is our x value. Quick, which tan is it, Austin? Nope. Yeah, the only one that's lost. All 4 of your denominators of 4 are going to have a tan value of 1. What could change from quadrant to quadrant? What? The signs, right? Okay. All right, and then denominator of 3, well, just like we mix these two up, common mistake is to mix these two up, but that's why we M-word memorize square root of 3 and 6. Obnoxiously, I'm going to hammer that into your brain, because if you know that one for sure, you can't mess this one up. It's just the flip of it. You just start saying to yourself, 3, oh, that's the other one. Doesn't start the party. That's the 1/2 square root of 3 over 2. You can see it'd be easy to mix those up. It'd be easy to mix those up. Learn my little tricks, then you'll never forget it. You need to know these for the rest of your mathematical life. Okay, so sine is the y value. Cosine is the x value. Okay, we need to know these. Not flashcard, note card, quick, but find it through the process I just modeled for you. Denominator gets me my ordered pair. Numerator tells me my quadrant, which gives me my signs. Cosine is the x, sine is the y, tans. That covers the whole unit circle outside of the quadrantals, and we went over those yesterday. Okay, so this is your opportunity in your homework when you get to number 7 through 12, you can take the shortcut and copy from the key. You can take the shortcut and have your unit circle in front of you. It should be nearby, but I want you guys to try going through the process that I just showed you. Denominator, get my ordered pair. Numerator tells me my quadrant, and then cosine is my x, sine is my y. Okay? All right, so let's go to page 32. Write this down. I'm going to do at least one with you, maybe 2. All right, so directions, a point on the terminal side of angle theta is given. Find the exact values of sine and cosine. Exact values just means leaving those radicals in there if need be, right? And so we're given a point. Guys, picture the coordinate plane in your brain. What quadrant would this one be in? Don't guess. Take a second and think. If I travel along the coordinate plane, what quadrant do I end up in? 4, right? Right 3, down 4. So let's draw a triangle in quadrant 4. Starting at the origin, my hypotenuse just goes out to the middle somewhere. Make a right angle always with the x-axis, theta at the origin. 3, -4. Why did you say quadrant 4? You were right. Because in your brain, I think, you traveled there. You went right 3, down 4 to get to this point. And that's how we came up with that right triangle. So the directions are to find sine and cosine. Pythagorean theorem is not something I need to see in your work, nor is it required on your FRQ if you had to do it. Oftentimes, especially if you're working with right triangles a lot, there's some special ones. There's a special one called a 3, 4, 5. If you have legs that are 3 and 4, your hypotenuse is 5. If you knew that, you don't have to do Pythagorean theorem. If you did Pythagorean theorem, guess what? You're going to still get 5. Okay? So we'll just skip Pythagorean theorem for that one. And now, if it helps again, you can label your angles with what their role is in SOHCAHTOA. So 3 would be adjacent, I'm sorry, that's opposite, and then hypotenuse. So SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. And that's it. I'm actually going to let you guys work. Okay? I'm going to put the key up. I'm going to come around and check on you. If I went too fast over something, you didn't get your question answered, you need some clarification, help with the homework, whatever, please do not sit there and suffer. Ask me for help. Work together, totally fine. I love hearing you guys talk to each other about math, not wrestling. You need to practice. Just so you can practice. square distance. We're not on the equivalent. So you still have to do it as L, and it's not on the equivalent. You still have to do it as L. So I always think it becomes a support those yet. Not always. That air, you know. That guy left.